Hello everyone, I hope you all are fine. This is my new video related to three-dimensional geometry. Class 12th student always find this chapter a difficult one because this chapter has many concepts as well as formula to learn. I'm going to discuss every concept related to three-dimensional geometry with you in detail through my videos. In this particular video, I'm going to start with the very basic of three-dimensional geometry, that is the concept of directional cosines as well as directional ratio. So, let us start. The first thing that I am going to discuss with you is directional cosines. So, what is the meaning of direction cosines? In 11th standard, my dear students, you have studied the concept of a straight line. In a straight line, you have studied about the slope. And what was the slope? Slope was the inclination of the line with the positive direction of x-axis. Okay. So, the role that was played by the slope in 2D in straight lines, the same role is going to be played here by direction cosines. Is it clear? So, it means the role of the slope is played by DC, direction cosines, in 3D. Okay. So, now you start seeing that what it is. Actually, what is the meaning of direction cosines? As we are talking about three-dimensional geometry, it means there are three axes: x-axis, y-axis and z-axis. Okay. And this is a vector, that is, this one is a vector. Okay. So, this vector is making alpha angle with the x-axis, beta angle with the y-axis and gamma angle with the z-axis. So, it is making alpha, beta and gamma, three angles with the three of the axes, that is x, y and z, and with the positive direction of x-axis. Like that they are making, this vector is making alpha, beta and gamma angle. So, these angles are known as directional angles. These angles are known as directional angles. So, our first point is, what are the directional angles? Angles made by position vector with x, y, z axis, and these angles we are representing by alpha, beta and gamma. Now, what is directional cosines? Nothing, it's very easy. The cos value of these angles, like alpha, it means cos alpha, that is cos alpha, and cos beta and cos gamma. So, cosine value, cos value of these directional angle is known as direction cosines, and direction cosines in short we write DC. Okay. So, direction cosine is nothing but, you can say that cosine of these directional angles alpha, beta, gamma, that are vector made with x, y and z axis. So, they are represented as cos alpha, cos beta and cos gamma. One more thing is there, that for our convenience only, sometimes we represent cos alpha, cos beta and cos gamma with L, M and N. So, L here is cos alpha, M is cos beta and N is cos gamma. So, the basic representation of cos alpha, cos beta, cos gamma through L, M, N, and cos alpha, cos beta and cos gamma are known as direction cosines. In short, we write DC. Okay. So, direction cosines means the directional angle, the cos value of the direction angle. And what are the direction angle? That is nothing but angles made by the position vector with x-axis, y-axis and z-axis. So, this is what the concept of DC. Now, let's discuss it further. To understand it, first of all, we are going to consider this diagram. Here you can see that these are the three axes, x-axis, y-axis and z-axis, and this is our position vector OP. Position vector you would have studied in vector algebra, but if you do not know, then let me tell you that position vector, a vector is called a position vector if its initial point it at origin. Okay, initial point at its origin, and the magnitude is represented by r. as P has the coordinate x, y, z, so magnitude of this OP will be x square, y square and z square. So this is what, at least this is the basic that you have already studied in vector algebra. So now you see that this is the position vector. So if we are going to draw the perpendicular on x, y and z axis from this point P, then what will happen? Let's see. If you are drawing the perpendicular on x axis, it will look like this. So now you can see that what will be created here. You can see that this is a right angle triangle OPA. So OPA you can see here, and this A angle is 90 degree. You can see here that this A angle is 90 degree, the perpendicular drawn on the x axis. And this angle, as we have already discussed, the directional angle was alpha. So this angle will be alpha, the angle made by the position vector with the x axis, that is alpha. So alpha is this. Now how to find cos alpha? Cos alpha is the cosine, direction cosine value of this alpha. So cos alpha will be base upon hypotenuse, and base is OA and hypotenuse is OP. So OA upon OP. And what is OA? That is small x. And what is OP? OP is the magnitude of this position vector, and that is nothing but r. And r is under root x square plus y square plus z square. Is it clear to you? That is very easy. I have drawn it in this way so that you can understand that it is a perpendicular and the angle made is 90 degree. Okay. Similarly, we can draw the perpendicular through P on y axis and the perpendicular from P on z axis. So like that, we have considered this triangle, we can consider this triangle like this, and we can consider that triangle also. So all the three triangles, if we are going to use, we can calculate cos beta, that will be y upon r, and cos gamma, that will be z upon r. Similarly, so clearly from the triangle OAP we got cos alpha, that is x upon r, and cos alpha, as I already told you, we sometimes call it L also. So it means we want to say L is x by r. So if we are going to cross multiply, then the value of x will become LR. Okay. Similarly, cos beta will be y upon r, that is m. So y, value of y will be Rm, and cos gamma, that is z upon r, and this is equals to n. So z is r upon n. So you can see all these values, that what is cos beta, that is y upon r. Similarly, we can calculate by drawing the triangle, and that is equivalent to m. Cross multiply, you will get y equals to Rm, and cos gamma, that is z upon r, equals to n, and that is equivalent to z equals to Rm. So this is what we are going to get all the three values. Now direction ratios, very easy. Direction ratios actually are the three numbers A, B, C, which are in proportional to direction cosines. It means what we want to say, that if we are going to take the ratio, means cos alpha upon A, cos beta upon B, and cos gamma upon C. If we are going to take this ratio, it should be a constant. That constant can be any number. Okay. So this is what we want to say, that ABC direction ratios are the three numbers which are in proportion to our direction cosines. Now how to calculate these ABC? Because there can be many numbers. So how can we calculate ABC which are in proportion to our direction cosines? So it's very easy to find out. Let's see. As in the previous slide we have discussed that cos alpha is this, and what is the value of x, that is RL, and cos beta, that is y upon r, equals to m. So value of y is Rm, and cos gamma we calculated like this, and value of z is Rn. Now we want, actually what do we want? We want A upon L, L is cos alpha, equals to B upon m, m is cos beta, and equals to C upon n, that is cos gamma. This is what we want, and this should be a constant. Okay. So just imagine that we call this RL A, Rm B, and Rn C. If we are going to put these value in place of ABC, in place of A, RL, in place of B, RM, in place of C, RN. Then what will happen? L will be cancelled with L. What will be left? R. M will be cancelled with M. What is left? R. N is cancelled with N, and what is left? R. So it means we got a constant, that is R. So actually, what is the conclusion? The conclusion is that A, B, C are nothing but actually X, Y, Z, that coordinate that we have taken for point P. This is what the conclusion. So it's very easy to find out. Now you discuss the conclusion. What is the conclusion? The conclusion says direction ratios of a vector are nothing but x, y, z. Or what is x, y, z? That are the scalar component of a vector. Scalar component of a vector. Suppose any of the vector is given to you 2i, 3j, 4k, and somebody asks you what is dr. So dr is 2, 3, 4, scalar component of the vector. Okay. And now what about the direction cosines? Direction cosines are L equals to x upon r, m equals to y upon r, and n equals to z upon r. So what is the mean, and where r is? You know very well, r is under root x square, y square, z square. So these are nothing but the scalar component of the unit vector of that vector. So how to find it out? Just see, just take an example. Suppose if you are asked to find out the direction ratios and direction cosines of this vector a1i, a2j and a3k. So dr, that is the scalar component. So you are directly going to write a1, a2 and a3. So dr is a1, a2 and a3. What about dc? dc, you know that these are the scalar component of the unit vector. How to calculate the unit vector of this vector? A vector divided by its magnitude. So just divide it by magnitude, you will get this, and by this you will get this result. So what are the scalar component now? a1 upon under root a1 square plus a2 square plus a3 square. Similarly a2 upon this value and a3 upon this value. So these will be our direction cosines. Okay. So direction ratio, directly the scalar component of the vector, and direction cosines, first of all you calculate the unit vector and then you find out the scalar component of the unit vector of that particular vector. So these are the DC as well as DR. So I think it is clear to you. Now you just re-listen this video, and if you have any difficulty you can ask. In the next video I will discuss some more concepts related to 3D. Thank you so very much.